All right. So what are we going to be talking about this week and next week? We're going to be introducing the concepts from lesson 3 in your required textbook, which is zyBooks. And so what is lesson 3 going to discuss? We're going to talk about variables, the importance of variables, and how and how do we what they are used for, and how we store data, right, in memory. And we use variables to do that. So data, there are different types of data that we can expect, right, that we should expect. And so as we introduce variables in our programs, we must determine, you the programmer must determine what type of data should I expect my user to enter from the keyboard to assign or to store in memory for this variable, right? So what type of data is this? And so this is what we're going to start discussing today, the various types of data that exist, and the various data types that are recognized by the Java programming language. Okay, so that's what we're going to talk about today. And so you can see, and again, I don't go, and you'll notice that my lectures don't just follow, each subsection at a time. I do cover things as I need to, and so some things will be out of order just slightly. But again, my goal is to introduce you to these concepts, and it's your task to go through the textbook and read and reinforce the concepts that we talk about in class, and introduce to you new concepts. So we will talk about all of these concepts, but in a creative way. Okay. And any questions for me before we begin today's discussion? Questions or concerns? And if there are individual questions or concerns, I'll be glad to stay after class and address any of those concerns. Right. And again, I see we have very few takers on displaying your video today. I do want to see more videos, sharing your videos. Okay, so yeah, so make sure that we the goal is at least once a week that you turn on your videos. Okay, so let's make that our goal and effort. All right. So with that being said, you should definitely have your textbook open, your programming environment. And so I'm going to jump right into our programming environment, because this is what I'll use going forward. And you'll notice going forward, I'm going to be using our programming environment. And again, you take notes any way that you see fit. Okay, that's not what my goal is. My task is not to, dictate how you take notes or what programming environment you use. So what you should do is definitely have some way to take notes, and you should have whatever the programming environment that you've selected to use this semester. Make sure you have those things open. And of course, your website. And so what I'm going to do is, this was the folder that we created, the project that we created for lesson 2. We've concluded lesson 2. And so what I'm going to do is I'm going to open up a new lesson for lesson 3. You'll notice the way that I'm demonstrating I'm demonstrating organization, right? We want to be organized in how we go about grouping our projects, grouping our programming assignments based off of the lessons that I've assigned to you. And so I'm going to create a new project, and I went up to new in my environment. If you see here the hamburger icon there, if I click on that, I'm going to, in file, I'm going to go to new and then say project. And in project, and if your window is not showing the whole thing, I like to drag it out so that you can see everything. And what I'm going to do is, in the same folder that I created for this semester, which is my fall 2025 folder, I'm going to go here and create my new project/folder. Right, project/folder. We're now in lesson 3. And I'm not going to add any sample code. So I'm just going to unclick that. If you forget to unclick that, no worries. But we don't need that sample code. Those are the only changes that I've made. And I'm gonna go say create button, and it's gonna ask me, do you want to open this project? Where would you like to open this project? I always select this window. Again, it's if you select any other option there, no worries. All right, so there's my folder slash project for lesson 3. And I wanted to do this up front because yes, we are going to be writing code today for sure, but I also am going to take some notes. And so going forward, from lesson 3 going forward, I will use my programming environment just as a whiteboard, so that you can see the notes as if I'm writing it on the board, or if I'm discussing things, I'm in class, in a face-to-face class. So I'll be writing notes in my programming environment as well as I'm going to be programming, okay? All right. So with that being said, I'm going to right click on my lesson 3 folder. And again, this is just me. I'm taking notes this way. You don't have to, but if you see fit to do so, that's fine. I'm right clicking on my lesson 3 folder and I'm going up to new, and I'm going to just say create a new file. Okay, a new file. And this file is just going to be my notes for lesson 3, right? So I'm going to say lesson 3 notes. Okay. And this is my semester fall 2025. Okay, fall 2025. And I'm going to push enter. And so it's just going to create just a text file. It's just, all it is just a text file so that I can we can talk about new concepts. And I also have a way to keep my notes. So this is lesson 3. All right, and the topic topic is variables and assignments. Okay, so that's the topic for lesson 3. I can do that. That's fine. All right, so with that being said, I've gotten that started, and we'll add as we go along to the various concepts that we're going to be talking about and introducing throughout. Okay. All right. All right. So you can see some of the topics that we're going to be talking about in lesson 3. Variables. What are variables? Assignments. What are identifiers? Arithmetic expressions. And so we'll talk about what constant variables are, what mathematic methods, excuse me, math methods that are quite useful and helpful to solve some interesting problems. We'll also talk about type conversions, and you'll learn about various things like the various types of data types that exist, like characters and strings and other variables that exist. You'll learn about how to read an API, and you should have began that discussion as you watched the video that was required for last Thursday's class, when you saw the API, the documentation for the scanner class. We should have looked at the documentation and saw some of the methods and properties that were associated with the scanner class. But you'll learn more, and again, we'll talk about how to read Java API documentation. So very important to understand how to read the documentation. So yes, we'll talk about these things in lesson 3. All right, so with that being said, all right, we looked at our announcements. We're gonna now look at our you can open up your programming environment as well as the lecture notes and follow along with me. And our lecture notes, if you like, they are located on your course website. Okay, so they are available on your course website. You can follow along as we go over these new concepts.
Excuse me.
Yes.
My Zybook has not been able to work at all.
I'm sorry.
My Zybook hasn't been able to load at all.
I'm not sure. So you might have to close it. Did you close it and start it back up?
Yes, I also even tried a different server and it's still not working.
Okay, your internet was doing the same, need to use a VPN.
Oh, okay. Thank you.
I have the same problem. So is this a problem that a lot of you all are having? with zyBooks? To use your personal hotspot?
When I was at my apartment, it wasn't working, but now that I'm at school, I'm able to log on. So I think it might be the Wi-Fi in my apartment.
Okay. Okay, that's interesting. That's weird. And so the suggestion is use a VPN, yeah, to bypass your network, that's interesting. It should not be blocked. But again, I'll make note of that and also talk with the publishers and see if there's some issue why all of a sudden, because I've been using this textbook for 5, 6 years now, and I've not encountered that where you're being blocked. Okay, hotspot. Okay. Thank you for the suggestions and recommendations, and thank you for bringing that to my attention because I was not aware that this was even an issue. Okay. All right. Well, we won't necessarily need it right this minute, but we'll address it, and definitely at the end of class, I'll reach out to zyBooks. Okay. So thank you for that. So let's jump into our discussion for today as well. As we get started, again, you can follow along with me in your textbook, as well as your lecture notes if you that I've made available, or look at the slides on the screen. So what in the world are we going to talk about, and what you're going to learn about in this lesson? We're going to first talk about what identifiers are and variables, the various data types, and some operators, along with learning about how to use them. Okay. So what in the world is a variable? Well, a variable is nothing more than a container. And I like to use I'm a visual learner, and you can see in this slide here, you can see that bucket there. That bucket is a good example of what a variable is, right? A variable it stores data, right? It stores data. And so that's what I want you to be mindful of. And again, these concepts are not only relevant for this course, but also relevant as you teach yourself any programming language, right? So what is a variable? Variables allow us to store. And so why do I have notes here? So again, we're going to talk about variables, right? Variables, right? What are they? And so what we want to be mindful of is that variables are nothing more than ways to store data, right? Right? So that they are allow us to store data in memory. That is what a variable is, right? So think of it almost like a container. I'll put it in parentheses there, like a container. But the key thing that you want to remember is whenever we think about variables, I want you always to think about memory, right? Because that is what they're used for. They're used to put data, store data in memory, okay, in memory. And I want you to know that variables values change, variables values may change throughout the execution of a program. Okay, so that is a thing that I want you to be mindful of, is that's why we call it variable. A variable's value may change throughout the execution of a specific program. And so you definitely, be mindful of that, okay? And so when we think of how variables work, right, we want to be mindful that I always use it. I think of the analogy almost as a Walmart shopping plaza, okay? And how to when you're in a Walmart shopping plaza, the parking lot, think of those parking lot spaces as locations, right? In memory, right? Slots in memory. And so as cars come, do you agree with me with this, that cars will come and go all day, right? And park in the various parking spaces all day. Well, those allocated spaces, those allocated parking spaces allow cars to park temporarily and then to be replaced with other cars throughout the day. And so that's kind of how memory is. Memory is space that's allocated, and data can be stored there in that memory location, but can also be overwritten with other data as needed throughout the execution of your program. Okay. All right, so that is very important that we understand. And so again, but when we think of variables, the first thing we want to think of when we think of variables that we need to understand about variables is we've got to give variables names. And so what do we mean by names? And I hope you can see, can everyone see my screen pretty good here? Yes? Hope that you can see it pretty good. Okay. All right. So here, very good. So here, when we think of variables, we think of identifiers, right? Variables are given names. And so what are identifiers? Identifiers are nothing more than names that we give. So names that we, and I say we, the programmer gives either variables or methods, right? Methods. That's what we call an identifier. They're user defined. And so here, let me make that very clear. They're user defined. And so because they're user defined, we've got to, and every language gives you certain rules that we have to follow. Remember, we talked about learning a programming language, we have to learn the grammatical rules of that language. And so every programming language will have a set rules on how to go about giving names to variables or methods, right? How to give, when we have user-defined variables, then we've got to abide by the rules of that language. And so for the Java language, here are some of the rules that they've specified. They've specified that, you know, that identifiers must be a sequence of characters that consist of letters, digits, underscores, and dollar symbols, the dollar sign rather. And so those are the characters that we can choose from, right? Digits, underscores, letters, and dollar signs, right? We can also, when we're defining our variables and method names, we must start with a letter or an underscore or a dollar sign. It cannot start with a digit. So be mindful of that. These are the rules. We cannot use reserved words. And so we're going to look at what Java deems as reserved words in just a second. But when we come up with our variable names and our method names, we cannot use those reserved words, those words that mean something special to the Java language. We can't use the word true or false or null. Those mean something special to the Java language. And our identifier name can be of any length. So those are very important rules that we've got to, and you'll find that most of the other languages will have some similar rules. They may not be exactly the same, or may have some one or more additional requirements, but they look very similar. All right, so identifiers must meet these requirements. And so here is a chart that lists all of the required or reserved words that Java recognizes, right? And so here, reserved words you'll see, and I'm not going to highlight all of them, but you'll see like the word if, the word for. You'll see do and while and int. You know, we're going to learn about int and long and float, short, return, public. And so these are some of the things that, and again, do you have to memorize all of these words? No, but you're going to get used to using them and you'll recognize them and you'll know that these are off limits and these can only be used as they're intended by that language. And so another way that you can also recognize that you're using a reserved word is that when you're in your IDE, your programming environment like IntelliJ or like Eclipse, you're going to notice that these IDEs will, all of these rules that, first of all of the rules that were just identified here that we discussed are going to be enforced in your integrated development environment. Also, you'll notice that the reserved words that are recognized by the Java language, they will be highlighted in special colors within your integrated development environment so that and it's highlighted in special colors to remind you that these words can only be used as they are intended to be used. So that is one of another benefit to using an integrated development environment, is that these identifiers, as well as reserved words, are recognized by that environment. Okay. And if I have any questions or concerns, don't hesitate to stop me. Okay. And so when we think about, give me just a second. All right. All right. So when we think about um, the topic of this course, right, which is the topic of this section, right, variables, and that's really, variables are the heart of lesson 3, which you do need to get a good understanding of what variables are, right, and how they are used. Here's an example. And so when we talk about what are variables, again, have to be given names. Variables are given names. And so here, I'll just write that down here. So variables are given names, right? And we call those identifiers. Again, you don't have to write down everything I'm writing, but again, I anything that you know, this is as if I'm writing it on the board, or if we were in a face-to-face, but I wanted to highlight certain things that you need to be mindful of as we go with these concepts, okay? And so here, I'll try to make sure that you can see everything. And so when we look at variables, variables will we will always use, whenever we want to store values in variables, we've got to always use the assignment operator. And so if you see in this example, this is an example, and we'll talk about what this is formally called, but here's an example that you see highlighted of me assigning a value to a variable. You see the assignment operator. And so anytime we want to store data in memory, we must use the assignment operator. So let's put that down there. So anytime we store a value, we want to store a value in memory, we must use the assignment operator, which is that equal operator, right? Okay. And so anytime we want to store data in memory, store a value in memory, store data in memory, we've got to use that assignment operator. Okay, store data in memory. We use that assignment operator. That assignment operator is what you see right here. You see that how does the computer execute this statement? It reads from right of the assignment operator to the left. So what is it going to do? It's going to, whatever the value that's stored on the right, whatever the value that's on the right-hand side is going to be stored in memory for where the variable that you see on the left-hand side of the assignment operator is referenced in memory. So where radius, the variable called radius, where it's referenced in memory. So imagine, remember the analogy I gave a few minutes ago of the Walmart shopping plaza parking lot? Well, imagine that, let's say that I want to store the radius, right, in memory. So what am I going to do? I'm going to declare a space, announce that one of my parking spaces is going to be allocated for the variable called radius, for where I assign values to the variable called radius. So I've got to give a label to a space in memory, to the allocated space in memory. I'm giving it a label. And so right here, I'm saying, before I got to this statement that you see highlighted, I would have reserved or allocated space in memory for radius. And then when the computer executes this statement, that's when I'm going to store 1.0 at that space that I've already allocated. So we're going to talk about the order in which we need to do things, right? But here, this is just an example of a storing 1.0 in memory for the variable called radius. And then what am I doing right here? I am calculating, there's a mathematical statement here. I'm saying whatever's stored in memory, and this is how the computer is going to read this. It's going to read from right to left here, from left to right of the assignment operator. So here's going to read, it's going to go fetch the current value that's stored in memory for radius, which is 1.0, multiply that by the value that's stored in memory for the variable called radius again, which is 1.0. And then it's going to then multiply that all by 3.14159. And it's going to get whatever the ending value is. So what's going to be the result of on the right-hand side is going to be 3.14159. That's going to be stored in memory for area. And then what am I doing right here in this statement? This statement is my print statement. And here, what am I saying? The area is, and then I'm concatenating. Remember that what that plus symbol is doing is joining together what it's going to, the computer's going to go to memory and it's going to fetch the current value that's currently stored in memory for the variable area, which is 3.14159. And that's what's going to be printed right here in our output. And then for radius, and then what's going to happen right here, that value that's stored currently in radius is going to print right there. So again, we use variables to store values in memory, and those variables can help us do things like what you see right here. Given those values, given the inputs to those variables, we can then process or do something with those inputs to those that we've assigned to those variables. We can do something with them, right? And you see here, we're calculating the area. And given those inputs, we do we get the expected outputs is what we need to determine as we test to see if our program works successfully. And so down below, you see another example of us doing the very same thing, right? All right, questions or concerns for me? So if no questions or concerns, the next thing we're going to talk about is very important. I need you all to pay very close attention to this conversation. Why? Especially if you're new to programming. We're going to learn over the next few minutes, we're going to learn about variable data types, the data types that are recognized by the Java language. It's so important that you have a good understanding of these recognized data types. And so what do I mean by that? The types of data. So when we think of data types, so that's our third topic is data types, okay? That just simply means the types of data that can be stored in memory, okay? In memory. That's what we mean by the data types, okay? The types of data that we can store in memory. Okay, and so for every language, there will be certain recognized data types, and some of them overlap for sure. But I do need you to appreciate that, you know, that whenever you teach yourself a new language, you need to understand the data types that are recognized in that language, and so that's very important. Okay, so the various data types that exist is what we're going to be going over, and so. When we say data types, they fall into these various categories. And so when we say different categories, you'll see these main categories here that are recognized. The integer category. So anytime we think of the integer category, we're thinking of whole numbers. These are numbers that have no digits after the decimal place. They're whole numbers, and I'll give you examples of that. Floating point numbers. You see examples of floating point numbers as well, right? And then you see characters and booleans and strings. We're going to talk about each of these over the next few minutes, all right? Over the rest of this class period. All right, so the various data types, let's talk about them. And again, we're going to talk about them in categories. The very first category that we're going to talk about is what we call integers. And we look at examples of integers, and so these are our categories. Integers are whole numbers. These is what should we expect when we talk about integers? We're talking about whole numbers. Okay. I can type today. So whole numbers. So examples of that, of course, let's just look at some examples of that. When we think of examples of whole numbers, right? We can think of things like what? 99 is an example of that. Negative 34. 289, right? Negative 3,567, and etc. Right? We kind of get the idea of what we think of when we think of whole numbers. These are numbers that do not have digits after the decimal place. Okay. So then in this category of data types called integers, all right, what are examples of recognized data types for the integer category. And so here are some examples there that you see there. So you see examples of, so data types that are recognized that fall into this category. So integer data types, I'll just say that, integer data types include the following. So byte is one, so byte. Now I'm gonna put in parentheses, what does that mean by space? So here's what I'd like for you to appreciate. So when we think of data types, I want you to appreciate this, that data types, and when you specify a data type for a variable, what are you telling the computer? So this tells the computer, so each data type tells the computer how much space to allocate in memory for this for this variable, for a variable. Okay, so that's what it means. Let me just go and bring this around so you can see it. So look, this is what is so important that you appreciate this, you all, is that when we introduce data types, we're telling the computer how much space to allocate for that variable, to store data in that variable. And so for each data type, you were gonna for every single category, it introduces or tells the computer how much space to allocate. So for instance, when we think of bytes, so here are the four categories that are in this category. Sorry, here are the four data types that are in the integer category. We have byte, we have short, we have int, and we have long. So for each of these data types that are in this category, so byte, we have short, each one of them will identify and specify the size to allocate space for. So for a byte, the data type byte, that tells the computer to, hey, computer, reserve 1 byte of memory for data that will be stored in this memory location. When you declare or define a variable as a short, we're telling the computer to allocate or reserve space 2 bytes of memory for data to be stored in this variable. Whenever we indicate that we're dealing with an integer, we're telling the computer to reserve space in memory for 4 bytes. 4 bytes. And lastly, but not least, when we specify that we're dealing with a long data type, we're telling the computer to reserve or allocate space in memory for 8 bytes, right? 8 bytes in memory. So again, do you need to memorize all of these? Again, it should be, it's kind of easy to remember, but I will tell you this about the Java language is that the default data type for this category is considered to be int. So I'm going to put a little asterisk beside int because this is the default. If you don't specify a particular data type, it will assume that it's dealing with an integer. Again, int is what you're going to mostly use in this class for sure. Mostly what I'll use in this class is for whole numbers, I will use integers, and that tells the computer to set aside or allocate 4 bytes of memory for any value that I assign to, any data that I assign to a particular variable that's of int data type, okay? So I hope this makes sense. Now, I love, as I said, I'm a visual person, right? So you're going to see me in your lecture notes or in diagrams. I like this diagram because look, this kind of gives you an idea from smallest to largest. We can see that byte is smaller than a short is smaller than an int is smaller than a long, okay? So FYI, so this gives you an idea of the size as it relates to each data type within this category. So what you need to be mindful of, and you see in this diagram, again, I threw images in to help you appreciate these things, is that we're thinking about memory. First of all, memory, RAM, we're referencing memory. So how do we store data in memory? Let's say that I prompt the user to tell me their age, right? I ask the user for their age. Well, then with that being said, what do I need to do? I need to declare or announce that I have a variable that's going to store this value. In this example, you can see that we've the identifier that we're specifying that's going to store that variable's value is age. So what do I have to do? I have to announce, which is what you see here, to the computer. Hey, computer, I have this variable called age, and I want you to set aside or allocate 4 bytes of memory. That's what this is doing on the left-hand side of the assignment operator. So it's telling the computer to set aside 4 bytes, and then after the computer sets aside 4 bytes of memory for the variable called age, then it addresses this right-hand side of my operator where I'm then storing data, storing the value 21 in that memory location. We'll talk about how to declare and initialize statements in just a second after we've gone over the data types. But that's what we're doing here basically. So here you'll see the variable name is called age. The value of the variable is 21, and we're putting that value in memory. So always, 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 again, as we go over these various data types, whenever we store data in these variables, we must use the assignment operator. All right, so this is the first category. We can see here that here are examples of values that could potentially be stored in variables that we've declared as an integer, right? As an integer data type, which we know that the integer data types have 4 data types that fall into this category. And the recognized or the default in this category is what is the integer or int. Questions before we move on to the next data type? We'll use these data types in an example. We're going to definitely program by the end of class today. We'll write a simple program. All right, so with that being said, let's move on to the next data type. The next data type that we're going to be looking at is what we call a floating point data type. Okay, a floating point data type. And so that's our next data type. So the floating data type, think of it like this floating point numbers. So floating point numbers. So these represent what? These represent values, right, that have digits after the decimal place, right? Values that have digits after the decimal place is what is recognized, what we mean by using this category. So digits that have, so numbers that have digits after the decimal place. And so examples of this would be, examples of, again, would be what, like 334.5 or 5.6 or 70.0 or negative 45.5 or negative 2,356.67854. Okay, again, I just want you to see some examples here. But whenever we think of that of data types that fall into this category, they have digits after the decimal place. They could be positive or negative, but they have digits after the decimal place. And I want you to appreciate, even this is considered to be a floating point number, 70.0. Even if it's 0, that's after the decimal place, that's also considered to be a floating point number. Now, in this particular category, there are 2 data types that fall into this category. So here we have, and remember in the first category, we had several. Here in the floating point, floating types, what falls into this category, we only have 2. And the first one is what we call a float. And the second one is what we call a double. And when we say float and double, so again, whenever we reference data types, any data types, that means the computer, you're telling the computer to allocate a specified amount of space based off of the reserved words that you give. So when I say reserved words, all of these words that you see here, float, short, int, long, float, double, all of these words are on that reserved word list because they mean something special to the computer. They know that tells the computer, when we use these words, that tells the computer how much space to set aside or allocate in memory. So whenever we use the word float, then that tells the computer, hey, computer, set aside 4 bytes of memory. Whenever we use the word double, we're telling the computer, hey, computer, set aside 8 bytes in memory, okay? Very important. So you can see that a float, that a double is twice a float, the size of a float. That's twice the size is allocated for a float. Okay, that's kind of important. I'll explain that in just a second. So float, example of that, definitely, if we think of pi, right, 3.14159, that's a good example of a float, right, the float. And here's an example of how we would declare a float. So an example of declaring a float, we would say something like this. So we would say pi, maybe a double pi equals 3.14159, right? That's an example of declaring a floating point number. And I'll say this, a floating point number, not a float, okay? But a floating point number. And an example, and I didn't do that above looking at examples of an integer. I'll do that in my slides here, an example of declaring an integer, right? We would say something like the following. We would say int age equals 56, something like that, okay? I just want you to see examples. So what I do want to, and I just went back and gave you an example for the previous category, okay? But for this category, floating point numbers, let me just like I did for integer category, what is the default type for floating point data types is double. So double is the default. So I'll put a little asterisk by it because it is considered the default for this category. Okay, default. And so if I don't specify the data type and it's a floating point number, then the computer is going to assume that it will declare it as a double, meaning it will reserve space for 8 bytes of memory. All right, so examples here. So any questions or concerns about the floating point data types and the different types that exist here? The different data types that fall into this category. No questions? All right. And again, we're going to look at these and I promise you we'll have more examples, but right now I'm just introducing them. The next data type, the next category rather, that I'd like you to be mindful of and that you'll read about in lesson 3 is what we call textual. This is our third category, and it's textual data type. Data types, right? Data type. And so here you're going to see, I'm going to put in here characters, just as these are characters. These represent characters. And so again, what data types falls into this category? Well, let's look at examples first of all. What are some examples of data types that fit into this category? Examples would be like, for instance, and see, these are characters from and we think of unicharacters, and I'm gonna Unicode. We'll look at that in just a second, but characters fall into this category. And what examples of characters are, like, for instance, F is a character. So any key, and I'm gonna put this in parentheses here, any key on the keyboard is considered a character. So let me be very clear. So any key, look right now, pause really quick for me and look down at your keyboard and at any single key. And now let me make that very clear here in your notes here. Any single key on your keyboard is considered to be a character or a char, which we're going to look at, the data type that falls into this category. So the F key, right? The F character is an example of a char. The capital letter Y is a character. The pound symbol is considered to be a character. Let's see what else. The enter key. I'm just going to say the enter key is considered to be a character. etc. So you get my point. Let me do a few more. The letter 5, the digit 5 is considered to be a character, right? And I put those in here because I need you to appreciate any, let's say for instance, let's say 4, that's also a character. Okay, so etc. Okay, etc. So what is the data type that falls into this category? The data type that falls into the category of character category, character type is char. C-H-A-R, char. Char. And char, anytime I declare a variable as a char, it tells the computer to set aside or allocate 2 bytes of memory. Okay, 2 bytes of memory. So char, again, any character on your keyboard is considered to be a char. Now, when we think of char, think of char as, and char is recognized. I'm going to put this in my notes here as well, right? Characters, any characters, when the computer looks at characters, the computer thinks of characters as numeric values, right? So whenever a char is given, the computer will recognizes characters as numeric values. So where are those values coming from? So here's what I would like for you to do for me, please, is I would like for you to open up a tab in your browser, and I want you to type in the following. I want you to type in ASCII, ASCII, and then table. So ASCII, and push enter on your keyboard. And I want you to just select the first one that you see there. Any of them will work, but I'm going to just select the first one there. So you can go directly to ASCIItable.com if you'd like. I'll put that in your chat. Either way, but ASCII table. This is very helpful here. So I'm going to drop this down so we don't see that. But this is what we call an ASCII table. And why am I referring you to the ASCII table? Because the computer recognizes all characters as numeric values. These are the numeric values. These are the characters. Characters are universal in all languages. The ASCII table represents a universal representation of all characters that are recognized in any language. And so here, you're going to see that for every character, there's a new numeric representation. For every character, there's a new numeric representation. And so, for instance, now what numeric representations are depicted here? Decimal, hexadecimal, octagon. And then you also have HTML representation for every single. So I'm going to reference your decimal notation here. So for instance, you all tell me what is the decimal notation, the numeric decimal notation for the lowercase letter e. Put it in the chat for me, please. What is the numeric representation for the lowercase letter e? It is, yes, 101. Very good. Yep. Well, what is the numeric representation of the capital letter E? Capital letter E. All right. So what you see here is that in our chart here, capital letters have a smaller decimal representation, numeric representation than lowercase letters, right? And so with that being said here, why do you think why are characters seen as numeric values? Because we can do the following. Because they're recognized as numeric values, and I'm going to put that in here. So because characters are recognized as numeric values, we can compare their values. They're using relational operators. And we'll talk about relational operators definitely in lesson 3 going forward a little bit. So maybe by Thursday, we'll get to some of the operators that are recognized. But when we say relational operators, let me give you an example of how we can compare values. We can compare characters. So with that being said, I can say, so, and don't worry about if you're not quite familiar with this, the every word in this example that I'm putting together here. But if E, the lowercase letter E, is greater than the capital letter E, come inside and do something. So you see this little example here. And again, don't worry about if you don't understand every single statement in here, but look at what it says here. It says, if the lowercase letter d is greater than the capital letter D, come inside and do something. So this is the kind of thing that we're going to be able to do because characters are recognized as numeric values. We can use operators like greater than or equal to, less than or equal to, equal, and we'll talk about what these are, some what we call relational operators. We'll talk more about relational operators going forward in this, and you'll learn about them in this lesson. Okay, so no worries yet, and we'll talk about there are other relational operators that we'll also look at. But see, we can, because characters are recognized as integers, because what exactly is this saying? What's going to be the truth value of this statement, you all? What's the truth value of this condition? When I ask the question, is the lowercase e greater than the uppercase E? Is that true or false? What I have highlighted. Is that true or false? Is the lowercase letter e greater than the capital letter E? Is that true? Is this a true statement? It is, or is it false? So how are you evaluating? I see you all putting answers there. Well, how are we evaluating? How is the computer evaluating this statement? It's referring to its numeric representation. And so in this, we know that what is the case? The lowercase letter E right here has the decimal notation representation. The decimal representation of the lowercase letter E is 101. The uppercase representation or numeric representation is 69. And so what is the computer really evaluating? It's really asking the question is that the following question is 101, is it greater than 69? That's basically what it's asking. Is it? And we know that 101 is greater than 69. So because this is true, right? Because that is, it is going to evaluate to be a true statement. That's how the computer, when it encounters characters, it looks at them like integers. Everybody good with that? Any questions over this? And again, this is going to be important, especially going forward. That's why I'm kind of spending a little more time here. But characters, remember, characters is any key on your keyboard is recognized as a character, and we can use it uses the ASCII table, right, to evaluate statements like you see here. All right. So the next category, if there are no questions, the next category that I want you to take a look at, right, is what we call logical data types, right? And I did not say this. Let me say this up front. There's only one data type that falls into the character type. And so we need to put an asterisk by this one because it's the only one. So anytime we think of the character data type, we're thinking of char, right? Char is the only data type that falls into this category. Last but not least, we call these, and I should say this, let me go up top here. These are examples of what we call primitive, and I need to emphasize that these are primitive data types. We're going to talk about data types that are not considered to be primitive. The primitive means basic data types, right? When we think of data types that are not, we're thinking of things like classes. Okay, and we'll talk more about that going forward for sure. But primitive data types, these are the categories that fall under primitive. The last category of primitive data types is logical data types. Logical data types is the last category of primitive data types. And what we mean by logical simply means true or false, right? True or false. So anytime we think of logical data types, we're thinking of true or false, okay, false. And the only data type that falls into this category, the only data type that falls into this category, just like the char data type, is boolean. And when we use the term boolean, we're telling the computer to reserve space in memory for 1 byte. 1 byte. Okay. 1 byte of memory. Okay, 1 byte. 1 byte. So it is also the only one in this category. So put a little asterisk by it. So anytime we're thinking of logical data types, the Boolean is the data type that we are referencing or referring to. I did not do this, and I want to make sure that, let me also give you an example. Let's go back to char really quickly before we move on. Here is an example of a char, the char data type. Let's put up an example of us declaring a char data type. So here, I would say char, and let's say maybe my middle init, like for my middle initial, and I would assign that, and my middle initial starts with the capital, with a L. My middle initial is an L. So you notice, and I did not specify this, and again, I apologize, is I did not specify that whenever we deal with chars, the values that we assign chars, and let's put that here in our notes, please. The values we assign chars must be enclosed in single quotes. I should have not jumped over that. That's so important, you all. That is one of those symbols that Java recognizes. Now, other languages may have a different rules, but in Java, Java requires that when we assign a value to a char, it must be enclosed in single quotes. Very important. How dare I move on without emphasizing that, okay? Very good. We may not be able to code, but we'll code all day, a majority of the day on Thursday for sure, when using these various data types. All right, so any questions over chars before we move into Booleans? So let's go to our Booleans now. Boolean is true or false. So anytime we think of a Boolean, we're thinking of true or false. So let me give you an example. Let's say this. So if I say, I'm going to give you an example. Let's say, if I say the following, Boolean has rained, okay? And if I initialize, I can initialize it to a true or false. So has it rained today? Maybe it has not rained today. So I'm going to assign that value, that Boolean variable's value to true. So this is an example of how we would initialize a Boolean variable, right? And so you're going to see here, what is the name of my Boolean variable? It has rained, and it's of type Boolean. What is the only values that we can assign a Boolean variable is true. Let's put that in our notes if you haven't already done so. The only values that we can assign a Boolean variable is either true or false. And I'm going to put a single quotes around them, even though they don't need single quotes. Please make note of that. But I'm just for emphasis, these are considered values. The only values that I can assign a Boolean variable is true or false. True or false. So you can see an example of me doing that down here below. So we do have about, 10 minutes, about 9 minutes. Let's write a simple program where we use a few of these variables, just very simple. And I want to bring in some of the concepts that we talked about in the video. And so here, let's right click on, if you're using the IntelliJ environment, I'm going to right click on the source file. I'm going to go up to new, and I'm going to go up to Java class. Right click on the source file. Remember, all of our files that we create within each project must be inside of the source file. Projects that we want to run. You notice my notes here are not in the source file. Those don't have to be. We could have, but we don't have to be. So here I'm going to say simple, let's say simple inputs. Okay, simple inputs. That's the name of this program, simple inputs. And I don't need to say .java, it will add it. it'll know that I'm referring to a .java file, creating a .java file. So here's my program called Simple Inputs. Remember, inside of our open and close parentheses, I want you to create your main method. And how do we do that? We say main, and we then use the tab button. So type in the lowercase letter main, M-A-I-N, and the tab button on your keyboard. And then what am I going to do here? I'm going to comment my closing curly braces, the end of main, and this is the end of the class. Thumbs up if you're where I am thus far, with me thus far. Okay, very good. Now, what I'm going to be going over right now, you should be familiar with this already. If you looked at my video, this should not be foreign language. Because this is an interactive program, what do I have to do? I have to import what class do I need to import in order to create an interactive program? Put it in the chat for me. Is that it, everybody? I see. Yes, you all. Yes, River, you had it right. Absolutely, Nick. Right. We have to import the scanner class, the util, that right, exactly. And so here we use that keyword import, right? Import. And then what do we say? We want to import the what? The java.util. And now we could say asterisk. You all should know what that means. That means bring in all of the classes that belong to the util package. Or I could specifically just say scanner. So I can push the enter key and it will select the scanner class. Remember, we've got to do that because this is an interactive program. We're going to just write a simple program, you all, today, but we'll use these more we'll write a lot more on Thursday's class. So here, because it's an interactive program, we need to use this. We need to import the scanner class. What are we going to do? What are we going to do inside this program? So here I want to say that this is example of use of simple inputs and storing values in memory. Right? I know this is here. What I want us to do, you all, let's do the following. I'm gonna write some comments first, and then we'll write our program. I'm looking at the time. We'll get out right at time. So here I want to declare a few variables here. And then I want to create a scanner object, create scanner and object. And you should know why, because after you've watched that video, and if you have any questions about the video, hang around after class. I'll be glad to explain anything. Okay. Here, I'm going to prompt user for their age, right? Their age. And then next, I want to read the age, right? And then let's print their age in 5 years. Okay, a simple program. Hopefully you all stay with me. So let's declare a variable called age, and we're going to talk more about declaring on Thursday. So how do we announce that we have a variable and it's called age? Well, here is a simple way to announce that. We're going to say int and then age. This is an example of where I'm telling the computer, hey computer, allocate 4 bytes of memory for this variable called age. Okay, for this variable called age. I'm going to store something in it later in the program, but this saves space in memory. You have to save space in memory for the variable before you store a value in it. I cannot emphasize that enough, or you will get an error. Here, what am I going to do? You should memorize this. What do we say? Scanner. And then your textbook uses what as its object? Put it in the chat for me, please. Your textbook calls the scanner object what? I told you it calls it throughout there. Not in the example that in the video, I use input, but what is the object name that your textbooks, Zybooks calls its object? SCNR. Very good. SCNR. So just for consistency, that's where your textbook is going to use SCNR as its object name. But we know that you can name it anything, right? But it's user defined. So scanner equals, right? A new, and then scanner parentheses system.in. This statement that you see right here, you just need to memorize it. It will not change. Okay, we're not going to change it. It's going to be that way. We have to create a scanner object called SCNR, and I'll put that in my comments. And then that has to be created in order for us to retrieve that value from the keyboard. Let's go ahead and prompt our user for the age. So system dot out dot print. I'm going to say print, and then I'm going to ask the user enter your age, colon, and a space. Don't forget your semicolon. Okay. And then I'm going to read their age. Reading their age, remember, so this is the value that I wanted. This is the variable that was going to store what I retrieved from the keyboard on the left-hand side of the assignment operator. What am I going to put on the right-hand side is I'm got to retrieve that value from the input stream. So what am I going to say? I need the scanner object to call the appropriate method to read this value. Put the appropriate method. What method do I need from the scanner class to retrieve the age that the user typed in from the keyboard? Put that in the chat for me, please. What method from the scanner class? And you see a list of them right here. After I put that dot, you see a list. What method did you learn about from reading our video? We need the next int. Absolutely. We need next int method. We need to call the next int method to retrieve the next integer from the input stream because we're dealing with a whole number, That value is going to be retrieved from the keyboard. As soon as the user pushes enter on the keyboard, it's going to be stored in the variable called age. And then now, because we have a value stored in memory for the variable called age, I can use that value, that variable. All right, so I'm going to print that to the screen. So system.out.println. I'm going to print how much that the user's age in 5 years. So your age, I'm going to say your age in 5 years is colon space, and I'm going to concatenate that with what? I'm going to concatenate that with my variable called age, and I'm going to add 5 to it. Yeah. This is going to go to memory, fetch the current value of age, add 5 to it. Now I'm not updating memory. I'm just retrieving the value of age from memory, adding 5 to it, and I'm just going to print that to the output stream, print that to the console. It's not going to modify the value that's stored in memory for the variable called age because you don't see an assignment operator. So it's not changing the age in memory. Here it's just printing the age in 5 years. I'm then going to run my program to see, given these inputs, do I get the expected outputs? And so it's asking me to enter my age on the keyboard here, enter age. And let's say that I enter 80 and I push enter on the keyboard, and you see what prints to the screen. Your age is in 5 years is 85. Thumbs up if you were successful. And more importantly, you understand how we got the output that we did. Given this input, do we get the expected output? I hope that you understand how we did this. You are free to go. No, we do not have a class reflection today, but we will definitely have class participation activity on Thursday. You all have a great rest of your week until I see you again on Thursday. I hope you learned something today, and take care. All right. All right.